Hello, Mr. Sutton here, bringing you the Pre-Cal Honors 4-6 Part 1 homework solutions on exponential equations using the common base method. For this problem, we see that there are three terms here that are all powers of 2. We have 2 to the x squared, 2 to the x, and 64, which is actually 2 to the 6th, and I'm going to rewrite it like that in just a sec. On the left side, I'm also going to clean this up a little bit by using my exponent rules. Since I'm dividing like bases here, I can subtract the exponents. So simplifying everything, I can write this as 2 to the x squared minus x on the left side equals 2 to the 6th on the right side. Since I now have 2 to something and that equals 2 to something else, I can cancel out those bases, leaving me with just x squared minus x equals 6. Now, since this is a quadratic, I'm going to get everything on the left and factor. So this is x squared minus x minus 6 equals 0. And now two things that multiply to negative 6 and add up to negative 1. That would be positive 2 and negative 3. So then I've got x equals negative 2 and positive 3. For this exponential equation, I think the easiest approach on this one is going to be common bases, but we'll have to do a little bit of prep work before we can make it happen. So I'm going to express everything in terms of one base. 2 is probably the best choice here, since 8, 2, and 4 are all easy powers of 2. 8 I can write as 2 to the 3rd to the x. 2 to the 7th can stay the way it is, and we'll rewrite 4 to the 9th as 2 squared to the 9th. Now I'll simplify all those individual exponents. So we've got 2 to the 3x equals 2 to the 7th times 2 to the 18th. At this point, I only want a single base on each side, so I have to merge these 2's over here. That means I'll have to add the exponents, so this will be 2 to the 25th. And now I can cancel out the 2's, which leaves me with 3x equals 25 for an answer of x equals 25 thirds. For the exponential equation in number 3, we see that 16 and 32 share a common base. They're both powers of 2, so probably common bases is the way to go on this one. I'll rewrite 16 as 2 to the 4th x minus 2, and then 1 over 32, that's really 2 to the negative 5th. So simplifying the exponent on the left here, we've got 2 to the 4x minus 8. Now we can cancel out the 2's, so that's 4x minus 8 equals negative 5. Adding the 8 and dividing by 4, we've got 3/4. For solving the exponential equation in number 1 here, probably the easiest approach in our toolkit would be common bases. 27 and 3 are both powers of, well, 3. We can rewrite 27 as 3 to the 3rd, and when we do that, we'll just make sure we have that inside a parentheses so that it doesn't get mixed in with this other exponent. Now we're going to have to simplify the exponent on the left here. So when I raise 3 to this power, I'm actually multiplying 3 times x and 5. So that's 3 to the 3x plus 15. Now that I have just 3 to some power, I can cancel the bases. And I've got 3x plus 15 equals 4x minus 1. Moving things around, I can move the 4x over here. That'll give me negative x. Subtract 15. That'll give me negative 16. So that means that x is going to equal 16. On this problem, I'm trying to solve this exponential equation. Now I see here that 8 and 2, those are both powers of 2. So let me rewrite everything as 2 to some power. I can write this as 2 to the 3rd to the x equals 2 to the 6th. Simplifying the exponent on the left, I've got 2 to the 3x. And then if I cancel out these 2's, these bases, I can write 3x equals 6. Which just means x equals 2. On this problem, I'm trying to solve for x. Now, on this problem, I noticed that these two terms, 1 over 27 and 9, these are both powers of 3. So if I rewrite both sides in terms of 3 to some power, I can get to the root of this without actually using any logarithms. 1 over 27 I can write as 3 to the negative 3. 9 I can write as 3 squared. And I'll just leave the 4x and the 6 outside of parentheses as exponents. So on the left side, I've got 3 to the negative 3 to the 4x. And on the right side, this will be 3 to the 2nd to the 6th. And at this point, I'm going to clean up my exponents on each side. So I've got 3 to the negative 12x, if I multiply those exponents together, equals 3 to the 12. Now I can cancel out my common bases of 3 and just write this as negative 12x equals 12. Dividing both sides by negative 12, I get x equals negative 1.